Data structure, linked list. In this section, we will learn the basic concepts of a linked list and the basic operation of a linked list. And finally, we will introduce other common linked lists. Before formally introducing a linked list, let's brush up on what an array is. An array is a data structure composed of a collection of homogeneous elements which are stored in contiguous memory locations. For example, an array that stores strings, an array that stores integers. The index of the element can be used to calculate the corresponding stored address of the element, but the array has a disadvantage. The size of data storage capacity must be known in advance. This is because an array is initialized, the size of this array cannot be changed. Therefore, when you don't know how much storage capacity you need, it is very suitable to use a linked list. Then, let's take a look at what a linked list is. This is a linked list, and you can imagine the linked list as a train. These carriages are called nodes, and the nodes mainly consist of two parts, data and link. Data is the data stored by this node, and the link stores the address of the next node. Several nodes are connected to become a linked list. The most basic structure is like a train with only one person in each carriage. Whenever there are passengers who need to take a train, it is required to add carriages. You can directly add an empty carriage, or you can also ask passengers to enter the carriage first, then add it to the linked list. Head refers to the node at the start of the linked list. That is the position of the locomotive. Therefore, when a train conductor wants to find out whether a passenger is on the train, for safety's sake, he needs to search each carriage in order from the locomotive. He can neither skip any of the carriages nor start the searching from the middle carriage. This also shows the very important characteristics of the linked list. It is directional and must go through all of them one by one from the beginning. Let's make a conceptual summary. Linked list is to connect nodes together through links, just like train carriages. Except for the two nodes of head and tail of the train, each node has two adjacent nodes. After learning the basic concepts of a linked list, let's perform a hands-on operation. Perform data structure of a linked list in C++. First, we create a structure called node, which contains two variables. The first one is data of integer type, which stores the data of each node. The second one is a node next of pointer type, which stores the memory address of the next node. The semicolon at the end is always missed. Everyone please be careful. Next, we will perform the functionality of addition and deletion in a linked list in C++. We will separately practice how to add and delete head, node, tail, and the nodes other than head and tail of a linked list. First of all, let's start with adding a node. Please perform adding a node before head node in C++. Likewise, we think of it as a train carriage. What if we want to add one more locomotive before the locomotive? First, get a new carriage. Next, ask passengers to get on the train, that is, to put the data in, then connect this new carriage to head. And the new head would be replaced by the new carriage. Since the new carriage is now the real locomotive, the one at head position must be changed to the new carriage. Let's visualize the whole process. It's just like adding a carriage to the front end of a train. The new carriage becomes the new locomotive that is the new head. Let's take a look at the code. First, define your own push function, which has two parameters that represent memory address of head of a linked list, and data to be added, node data. Next, add and initialize a node of pointer type in function, a variable named new node to perform an action of adding a node, and the newly added operator is new. Set data of new node to node data. That is to have passengers enter an empty carriage, set the next item of new node to head. Then, Set new node to head and it becomes the new locomotive. I will explain the small arrow. A small arrow B. It is used to get member B and A, such as new node small arrow data is to get member data in new node. Then use equal to change data of new node to node data. New node, small arrow next means the next item of new node. It will be used frequently later, and you will be familiar with it after using it a few times. Now that we know how to add a node before head node, next we would add a node at the end of a linked list. Please perform adding a node at the end of a linked list in C++. If we take train carriage as an example, it would be get an empty carriage, then ask our passengers. That is the data to get on the carriage. Next, find the last node, then hitch the new node to the end. The whole process would look like this. Add a carriage that is a node to be added. Next, find the node whose link is null, and this node would be the last node in the present list. After that, point the link of this node to the new carriage and set the link of the new carriage to null. Then the task of adding a carriage to the end of the train is completed. Let's take a look at the code. First, define your own append function, which has two parameters. That represents the memory address of head of a linked list and data to be added node data. Next, add and initialize a node a pointer type in function, a variable named new node. Add a node a pointer type, a variable named current, and point it to head. Set data of new node to node data. Then there are passengers on our new carriage. Set next of new node to null. Null means a null value which represents there is no carriage after new carriage. Determine whether the node to be added is the first node. If yes, the newly added node, new node, would be head itself. Determine whether next connected to the present node current is unequal to null. If it is not null, it means current is not the last node. So, continue to search backward. Until link of node is connected to null, it means the null is now the last node. Hence, we point the link of the present node to new node. The way of adding a new node at the end is completed. The last exercise for adding node is to add it to a position other than head and tail. Please perform adding a node to the position other than head and tail in C++. If we take train carriage as an example, likewise, get an empty carriage first, ask passengers to get on the carriage, search for the position to be inserted with carriage, and confirm this is not head or tail. Connect the link of the new carriage to the next carriage. Then connect the link of the previous carriage to the new carriage. Why does it sound so complicated to add a new carriage to the program? Don't worry, let's dismantle it step by step. First, get a new carriage to be added. After we find the position we would like to add to here's the thing, the address stored in the link of new carriage must be pointed to the next carriage. A quick brush up. The link in each node is responsible for storing the address of the next node. After setting which node after the new carriage, next would be the node before the new carriage. Likewise, we need to connect the link of the previous node to the new carriage. As such, our new carriages would be successfully added to the linked list. Let's take a look at the code. Define your own insert function, which has three parameters that represent the memory address of head of a linked list, position to be inserted, num, and data to be added, node data. Determine whether this list exists. Set criteria to exclude the condition of adding nodes at the beginning. Add and initialize a node a pointer type, a variable named new node. Add and initialize a node a pointer type, two variables named countList and current, and point them to head. Use while loop to calculate the length of a linked list and store it in listlen. Set data of new node to node data. If the position to be inserted exceeds the range of list, it would display input number over list length. Otherwise, it goes to for loop, point current to the one before the position to be inserted, then insert new node after current. After learning how to add node to linked list, let's take a look at the process of deleting node from linked list. It would be explained in 3 aspects of deleting head node, deleting tail node, and deleting middle node. First, please perform deleting the head node of a linked list in C++. We take train carriage for an example. It would be 1. Record head to be deleted. 2. Set the second carriage as head. 3. Remove the first carriage. Let's dismantle the process step by step. First of all, we need to have a temp to store the position of an original locomotive. Then, point the position of head to the second carriage. And the second carriage would become the new locomotive. Since we use temp to store the first node to be deleted in advance, we could delete it. Think about what the meaning of this step is. Why do we need a temporary node? If we directly set the second carriage as head, we would not find out the position of the first carriage. Although the length of the first carriage stores the position of the second carriage, this is a one-way position recording. Therefore, if temp is not used to storing the position of the first carriage in advance, no one would know where the first carriage is. If we can't find it, there's no way to delete it. Let's take a look at the code. First, define your delete first node function, of which the parameter represents the memory address of head of a linked list. Determine if this linked list is null. Create a temp node to store the position of head. Then point head position to the second carriage. Finally, delete temp node, which is the original head node. After deleting head node, let's give it a try to delete the last node. Please perform deleting the last node of a linked list in C++. If it's a train, that is to remove the last carriage. If it's linked list, would be more troublesome. 1. Find out the second to last carriage. 2. Remove the last carriage. 3. Set the link of the second to last carriage to null. Let's see how to do it. Do you still remember the train conductor can only patrol each carriage one by one starting from the locomotive? So we have to search one by one from the beginning to see which carriage after the next link is null. As such, this carriage is our second to last carriage. Why do we have to find the second to last carriage but not the last carriage directly? It's because if you directly find the last carriage and then delete it, when we want to set the link of the second to last carriage to null, we have to search from the beginning once again, because each node records the address of its next node. So we still don't know where the second to last node is. If one patrol is enough, why 2? Why not find the second to last one directly to obtain the positions of the second to last and the last ones at the same time? It's like killing 2 birds with 1 stone. After the concept is understood, let's go to the code part. First, let's define your own delete last node function, of which parameter represents the memory address of the head of a linked list. Determine if this linked list is null. Determine if there is only one node in this linked list. That is, if head is linked to null. If so, it represents head is at the beginning as well as at the end, then delete head. Search all the way starting from the locomotive, and the goal is to find the second to last node, then delete its next node. By identifying whether the node after the next of each node is null, we would determine whether the next node is the last node. It's able to delete the next one of the second to last node, so that the last node would be deleted. And finally, we'd like to practice how to delete the middle node. Please perform deleting the nodes other than the head and tail in C++. If train carriage is taken as an example, the steps would be 1. Find the carriage to be removed and the ones before and after it. 2. Record the carriage to be removed. 3. Connect the previous carriage to the last carriage. 4. Delete the carriage to be removed. It's like removing one of the carriages from the train. Let's search one by one from the beginning, then find the previous node to be deleted. Its next item is the node to be deleted. We record the node to be deleted so as to find it later. Then connect its previous carriage to its next one, which is the carriage after the next. At this moment, we can follow the position which was recorded just now and delete the node we desire to delete. Let's take a look at the code. Define your own delete middle node function, of which parameters represent memory address of head of a linked list and position to be deleted num. Determine whether there is only one node in linked list. If so, it represents the head is at the beginning as well as at the end. Such conditions should be excluded. Add and initialize a node of pointer type, two variables named removePre and countList, and point them both to head. Add and initialize a node of pointer type, a variable named remove. Use while loop to calculate the length of a linked list and store it in listlen. If the position to be inserted exceeds the range of list, it would display input number over list length. Otherwise, it goes to for loop, point removePre to the previous position to be deleted. After finding it, set the next item of removePre to remove. As such, we would complete the setting of the previous node of the deleted node, and the node itself to be deleted. Then point removePre to next. Next is the next item of the node to be deleted. And finally, delete remove so that the node to be deleted can be deleted. So, how to display the linked list? This while loop would traverse all nodes and display the value of each node. When the node is equal to null, output null. Next, call the function we have written in main function. Call the written functions in sequence. Append to add new nodes at the end. Push to add new nodes at the beginning. And insert to add new nodes at the designated positions. Delete first node to delete the first node. Delete last node to delete the last node. Delete middle node to delete the designated nodes in the middle. And after each call, output linked list to observe the change. What kind of output will we get? This is the linked list displayed each time after we call the function 8 times. Let's do it step by step. We add a node 10 at the end of a linked list which is null. Add a node 20 to the head of a linked list. Add another node 30 to the head of a linked list. Add a node 40 at the end of a linked list. Add a node 50 after the second node of a linked list. Delete the first node of a linked list. 30 is deleted. Delete the last node of a linked list. 40 is deleted. Delete the node after the first node of a linked list. 50 is deleted. Data structure, linked list. In addition to normal linked list, are there other types of linked lists? Let's take a look at other types of linked lists. Doubly linked list refers to a linked list of which each node has two links, one pointing to the previous node and the other pointing to the next node. Therefore, in practical operation, you have to distinguish whether the link of each node is forward or backward. And when the last node is connected to the first node in linked list, such linked list is a circular linked list. Let's take a look at our homework. Assignment 1. Create a list which contains 3 types of data: seat number, name, and score. Assignment 2. Add 4 pieces of data in order. 1. Shangyu Jiu, 80. 5. Yuhui Jiang, 50. 3. Hongyun Huang, 60. 6. Xingyi Fang, 70. Homework 3. Due to a change in schoolwork, some of the classmates are transferred to another classroom and the data have to be deleted. Please delete data number 6. Let's take a look at an actual implementation of a linked list in this section of list. Look at what the problem requires. Please perform functionality of addition and deletion of a linked list in C++. Add, delete head node. Add, delete the last node. Add, delete nodes other than head and tail. How to solve this problem? The code for this problem is very, very long. Everyone, please follow me. First of all, let's write the structure first. Include IOStream using namespace stand. Then the main code area. Return 0. The following additions or deletions, we will use function to write them all. That's because what we want to do is linked list. So first of all, we create struct node. A structure which is node. In node, we enter its data. We use the form int for the data here. It could be the first node, the second node, etc. Next, we give it a link. We call its link pointing to the next node. So we call it next. Pay attention to the structure part. Add semicolon after brace. Please pay particular attention here. Please add a semicolon at the end. What's next? Next, we just said, these functionalities of addition and deletion, we use function for processing. So we can declare these functions first. Add and delete the first node. Add, delete the last node. And add, delete nodes other than head and tail. We call the first added node push. What is the type of push? This involves what we want to return. This time our function would mainly be based on returning its first node. That is how we look at linked list, would be where linked list starts. To find the position of this linked list, so regarding the type part, we will use the position of node. As such, we will return where it started, so that we can find its linked list. We'll think about what to put in it later. Let's complete creating the function first. Next, regarding adding and deleting the last node, we use append. This is about adding the last one. One more thing, regarding the part for addition, is to add node other than head and tail. We use insert here. To delete the first one, we call it delete. first, delete first node. To delete the last one, we call it delete the last delete. Delete last node. Next, to delete the middle one, we call it delete the middle. Delete middle node. In addition to addition and deletion, we would like to know what on earth the linked list looks like now. After we took a lot of actions about addition and deletion, what the look of the linked list is after all, we would need to use display list. To display this linked list, so we would have a display function that needs to be processed. For this function, it does not need to return the position of a linked list. I just need to know to display it. Just do cout, so it doesn't return anything. Use void as its type. Next, we will try hard to complete these functions. Let's start from the first one to add at the beginning. Starting from this push to add at the beginning, we can first think about what we need for the parameters inside. As I just mentioned, to find the position of a linked list, we would need to know where it starts. So in it, we need to tell this function where on earth this linked list starts. So we need to introduce head for it. Next, what else do we need to do? Because it is to add a node, we would need to know what information about the node I want to add. So we need to know at least one piece of information. That is what data of the new node would be. So we introduce node data here to tell this function the data of the node I want to add. Okay, let's take a look at how to write this push. After declaring it, we can write it below the main function. In this way, when you look at the main function, it would be less messy. What's next? Next, we would write this function. Push, this is to add at the beginning. Write the parameters just mentioned. Need to know where it starts. Then the data of the node you want to add. Let me add an annotation that it is to add at the beginning. Add it at the beginning. Next, what are we going to do? At first, we introduce data. We want to create to add a new node. So we create a new node at the beginning. Later on, this new node would be the node we want to add to the linked list. So create a new node. Create its new node. New node. The new node ahead is our variable name. And then here behind is to create a new node. Create a new node. Okay. Next, after creating a new node, we are now going to put this node into our linked list. Before putting it into the linked list, we need to give it the information of this node. This node, we would need to know how much its data is. Data is the node data we just entered. the node data in the parameter. It's the data of our new node. And because we want to add it at the beginning, that is, this new node would be the first node. The first node. It would be the first node in the linked list. Therefore, its next node would be the original one, the original head. For this new node, its next node would be the original head. Accordingly, my new node would become the forefront one. Then I need to return something to tell my function to return to the main function about which one the present new head is. Therefore, I changed the head to new node because new node is now the new head. Since I put something at the forefront, the new one is the new head. As such, when I return the head, our function would know, oh, the new head is the new node. This is how we add it at the beginning. I'll let you guys think about it and try writing it a little bit. Okay, if you've not finished it yet, you can pause. Next, we're going to look at the next function. Add it to the last. Add it at the end. For this function, its parameters are the same as those of the one added at the beginning. Therefore, we also need to know what the head of our linked list is. And the data of the node to be added. So, its parameters are the same. Then let's try writing it. Add it at the beginning. Oh no, add it at the end. So now we want to write the part for adding it at the end. Then here it would be a little more complicated than that of addition at the beginning. Write the function and its parameters first. What we need to do in the beginning is the same as above. That is to create a new node. Create a new node. Create a new node. What's next? The next step is a bit more complicated. Since we need to add it at the end, we need to know what on earth the tail is. In this case, we would create another node. It's called the current position, current. Let it start from head in the beginning. This current will help us start from the beginning. Then search backward one by one. Find the end and stop. This is its functionality. As such, we would know where the end of this linked list is. Then we would do the same as above. Process the information of new node first. For a new node, its data would be the node data we just entered. What is it at the end? It's next. Because it is at the end, its next would definitely be under the condition of null. It's at the end. The next one is under the condition of nothing. So we enter null here. It is null. What information is needed? If here, this head itself is in fact in null state, that there is nothing in the whole linked list, then addition at the end is equal to that at the beginning. Therefore, at this moment, we need to kind of process it a little bit, since our head would be changed. Initially, the head is null. After I add a node, the head would become the current node. So we have to process it separately here, so it won't be confusing. Let the head become new node, then return it this head. This is under the condition that the head is null. This part needs to be additionally processed. If the head is not null, we can start to find where on earth the tail is. Use a while loop to search where the tail is. The way of our searching is a bit more special. We would not directly use it like this. We can look at the way we want to look for. If we write this current node as null, if it is not null, we would look for the next one. This is a wrong version that people are more likely to write. Remember, this is the wrong version. This one is a wrong version that everyone is more likely to write. If this current node is not null, I would let this node become its next one. It's a bit like there are 1, 2, 3, 4, 5, and 6 in the whole list. I start from 1. 2 is the next one to 1. If it's not null, I will go backward. 3 is the next one to 2. If it's not null, I will go backward. 4 is the next one to 3. If it's not null, I will go backward. 5 is the next one to 4. It's not null, so I go backward. 6 is the next one to 5. If it's not null, I will go backward. The one next to 6 is null. But since my current one is not null yet, I would feel like, oh, I should go backward. At this moment, my current would become the one of null. It becomes a null. I don't even know that the tail is 6 at all. This is because I go backward to a position of null. Therefore, when we do the searching here, note that our condition would be whether the next one to current is null. If the next one is not null, I will go backward. So when I go to 6, its next one is already null. I would not go backward. Therefore, my current would point to the position of 6, the position of the last node. Okay, now we know the current is 6, the position of the last node. We would let the next one to current point to the new node we want to add. New node. Because new node is the last node, so the next one to the original tail is connected to new node. This would be okay. Then similarly, return the head. This is the way we add it at the end. Everyone take a look. Give it a try. You can also take a pause and complete writing the code first. Next, we're going to write the next thing. Add nodes other than head and tail. Here is our insert part. The parameters here. First of all, they would be the same as the above, but it would have one more parameter. Because I added it at other positions other than head and tail, but I don't know whether it's the second, the third, or the fourth one exactly. So I would need to note an additional piece of information. It's called Where on Earth I Want to Add. Same as above, we at least have to know where the head is at the beginning. After that, I would need to know a piece of information called Where on Earth I Want to Add this number to. Likewise, our node data, for example, the newly added thing, what is its data? Therefore, more particularly, I at least need to know where we want it to be added. Okay. Let's write it here. It becomes neither head nor tail here. So we call it inserting into a certain position. Let's write out this thing. Insert. Enter the parameter entered just now, note the information of this head, and the information about where it wants to be placed. And for the new node, how much its data is exactly. Write out this information. What's next? The next part would be a little more complicated. First, we need to do some exclusions for certain conditions. Here is to add at a position other than head and tail. A simpler condition to be processed is if the position which the user inputs, if it is at the beginning or it is at the end, we just ignore it. That's it. We would ignore it if it is at the beginning and the end. It is to tell that its input is wrong. That's it. Okay. If it's not, we can process it then. Therefore, when we deal with it, we may need to know where on earth is this number. At first, let's assume that its head is null. It's just the same as just now. That is, it's a troublesome condition that the head is null when we add it at the end, because it is inserting now if the head is null. In fact, basically, our number should be wrong. If I want to exclude, inserting 0 is excluded. The inserted position is 0. And if the inserted position exceeds the tail, no matter what number you input, in fact, it would be excluded. That is, at last, there should be this number if it is equal to 0 or it exceeds the length. We will talk about how to calculate the length later. Exceed the length. Here, I first write down the variables that I want to create later. So if this number is 0, or if it exceeds the length, it also counts if it is equal to the length, because we don't want the tail either. If it exceeds the length, we would tell the user that your input is wrong. Then it comes to the end directly. No need to ask it to re-input something. Just tell it that the input is wrong, and that's it. If the user wants to do the insertion again, the insertion has to be written once again, then give it a better number. That's it. So, it's not particularly important whether this head is null and whether it is processed exactly, but you can do some additional processing. Tell the user to say, please don't input null. That is, it can be null or the like. It would also be okay if it's not processed. We can also exclude it later anyway. The latter condition would be that it is equal to 0 or exceeds the length here. We will tell the user to say, your input is wrong. That's it. Let's write wrong input position. But please pay attention to here that there is the length of this linked list. How long is it exactly? We must first calculate its length. Therefore, this if part is actually far below. Since we haven't calculated the length yet, we create a variable first. It will be used to calculate information on length. This list len is used to calculate length. After that, we would count how long our linked list would be. Before calculating the length, we would first create what we should create. Our node. Same as above, create a new node first. Information of new node. Then we create a thing to get the length. It is a node. We will use it to get the length later. It starts from head in the beginning, then slowly goes to the end, which we want, and calculate the entire length. Same as above, there is a current node. When we want to insert it into the middle later, then we use this current to help us run to the position we want to insert. Then, after creating the information, likewise for new node, we need to put data in. But here our next one, for example, next of new node, can't be put in for now, since we don't know how much it should be at this moment. This is because we insert in the middle. We are not sure which on earth this next one would point to, therefore let's not do anything for now. Next, we're going to calculate the length. Calculate its length. For length calculation, we can use while loop. It's almost the same way as above. More especially here, let's see when it would be null. Every time it goes backward, as long as it is not null, it goes backward. My count list len would increase, length would increase. For this count list, we let it run backward to the next. It directly goes to the end here because let's assume our length is 1, 2, 3, and 4. It starts from 1 in the beginning. 1 is not null, it runs backward. Therefore, my length would become 1 now. If 2 is not null, it runs backward. So our list len becomes 2. 3 is not null, it runs backward, so list len becomes 3. 4 is not null, it runs backward, so list len becomes 4. Finally, it becomes null now. I'll leave this while. Therefore, this is the way of calculating the length. After calculating the length, it goes to the if part we just wrote about. Confirm whether the numbers and positions input are not wrong. If it's wrong, just display it's wrong. If it's not wrong, we can proceed with the writing below. If what is input isn't wrong, we should insert the thing into the corresponding position. Where would this position be? Use our current to run. Run to its corresponding position. For the position it runs to, we would start from where I is equal to 1. Then it runs to where I is smaller than n. I++. Then let current run and run and run and run and run all the way. Run to the next every time. Run and run and run and run and run all the way. Run to the previous position of the node we want to insert. Its previous position. Therefore, everyone can also think about why it starts from where I is equal to 1 and ends at where I is smaller than number. I can write it down a little bit. Let's assume we have 1, 2, 3, 4, 5, and 6. The position we want to insert into is that, between positions 3 and 4 for inserting one thing. So, the num we input, what I should have input is 3. Let me use 0 so that everyone can understand it better, since what we input would be 0, 1, 2, 3, 4, and 5. If I want to insert between 3 and 4, it should be like here between 3 and 4. I want to insert into position number 3. Position number 3. I insert A here. I want to put in A here, which is 1. The 0th, 1st, 2nd, and 3rd positions. The 3rd position. Okay. This is where our num would be displayed. It wants to be inserted into the 3rd position. I will start finding. My current would run until it points to number 2. Therefore, its condition is that current is at 0 at the beginning. It's at the position of head. I have it run once, then run to 1. It runs twice, then runs to 2. So I only need to have it run twice. It's equal to 1. Then equal to 2. It ends when it's equal to 3. It would be only running twice. Okay. After running twice, regarding this for because there is only one line, we can omit the brace. After running twice, we would let this new node, its next one. We finally know where its next one points to. Its next position would be the next one to current. What does it mean? The 0, 1, and 2 input just now, then 3, 4, and 5. Our new node is A. I'd like to put A between 2 and 3. And current is 2 now. The next one to current is 3. So I would let A, its next one, point to the next one to current. It would let A point to 3. After A points to 3, now we have it half connected. A points to 3 and it is half connected. A points to 3. The next one to A points to 3. After that, we would have the above current connected. Because for current, its next one is now still 3. It's not connected well, therefore, we have the next one to current connected to our new node. It would let 2 point to A. As such, our A would be inserted in the middle. That's it. This is the way of writing we want. Lastly, have our head returned, and it's done. The code here is a little bit long. I erased 2 spaces first so that everyone can see more things. So everyone can practice how to deal with this piece of code. You can pause for a while and try writing it a little bit. Okay, now we have solved the 3 ways of addition. Insert it at the beginning, add it at the beginning, add it at the end, and insert it to certain position 3 ways. Next, we're going to deal with the 3 ways of deletion. How to do it for the 3 ways of deletion? First of all, similarly, we create the parameters first. The thing we want to delete at the beginning. Similarly, we need to know where the head of this linked list is. Then that's it. Because we'd not like to add anything. There's no need to have new information for data. We just want to delete things. Therefore, to delete the head, we only need to know where the head of a linked list is. Then find the head and delete it. It sounds pretty simple, right? Let's try writing it. We want to delete it. Delete the head part. Then complete writing this one first. Delete first node. Enter the information of our head. Similarly here, if its head is null, it represents in fact that I'd like to not delete anything. Just return something null. Just tell everyone that it is also null. That's it. Next, we're going to actually delete the head. But for deleting the head, can we just delete head? It doesn't seem quite okay, because if we delete head directly, we still need to return the position of the new head eventually. However, after I delete head, it disappears. It's not quite okay this way. Therefore, we will create a temp first. Temp node, a temporary node. Store the position of head. Next, change head to its next one. Because after I delete the head, the new head is the next to the present one, the second node. So change head to the next one to head. As such, at least the information of head would be retained. Then, when I want to delete it, becomes delete. Delete temp node. Since the position of temp node was at the beginning just now, I delete it, so that I can delete the thing at the beginning. As for head, it is the new head now. Therefore, if I return head, I would get the position of the new head. This is the way we delete head. Very short, right? You can try writing it. You can pause if necessary. Okay, let's take a look at deleting tail. The parameter for deleting tail is the same as that for deleting head. Just need to know where the head of the whole linked list is. We can find out the tail by ourselves. So let's write it down. Delete tail. Of course, it will be a little longer than deleting head. After all, we still need to find out where the tail is. Delete tail. Enter the required information first. Next, similarly, if head is null, we directly return null. There is a condition which is more special here. Here, if the next one to this head is also null, if its next one is null, it represents that there is only one node in my whole list. If I delete tail, it would be to delete this node. And at this moment, my head would become null. There's only one node, and after I delete it, it becomes null entirely. So at this moment, it also returns null. Therefore, we have to additionally process it here. delete head, then return, and the entire list becomes null. That's it. In addition to the two conditions, we are going to start looking for the tail we want to delete. Which one is its previous node? Because we want to delete it, but we would like to delete 1, 2, 3, 4, and 5, the fifth person. If we just directly look for it all the way, find the fifth one and delete it, it's not quite okay this way, because we would not know where the fourth one and its next one would be connected to. We need to process the fourth person and its next one. If we delete 5 directly, originally for the fourth one, its next points to 5. Then it would be confusing. The fourth person would be a bit confused, so we would have to find out the fourth person first. Process its next one well. Then find and delete the fifth one. Therefore, we create a node here. It would be second last, the second to last one. Similarly, start from head. What we want to find here is whether the next one is null. How we find the last one is to see if its next one is null. Then, if I want to find the second to last one, just see if the next two are null. As such, I can find the second to last one. If not, then it goes backward until its next two are null. It represents it is the second to last one. After finding it, we can delete it. Delete its next one. The next one to the second to last is the last one. So when we delete, it's to delete the last one. Delete the last one. Then this second to last thing. Although it is now called the second to last one, but after we deleted the last one just now, it becomes the last one. So for its next, we will let it point to null. It becomes null. And finally, return head. This is the way we delete tail. Everyone can take a look. Then practice writing the code. Take a pause if you need to pause. Okay. Next, let's take a look at deleting node other than head and tail. Delete the middle node. In this case, parameters are the same. We have to first know where the head of the whole linked list is. Then, the same as adding a middle node. We need to know which node it wants to delete exactly. So we need to know the information of the position for the node it wants to delete. Remember, this is the position, the information of position. Accordingly, we can delete the node in the middle. Similarly, it would be a more complicated condition to delete the middle one. Write the function first, and then its parameters. After that, what are we going to do? We want to delete it. Similarly, we can do the things in the same way as we did for doing addition just now. Add to a certain position. The condition here is in fact pretty much the same. We also need to count how much the current length of this linked list is. If the thing input is the head or exceeds the tail, we have to tell it that there is wrong input. The condition is in fact basically the same, so we can also do copying a little bit. Let's use copying for revision, so as to let everyone compare, which is not quite the same. So copy the things above to here. Similarly, if the head is null, this paragraph can be kept. The paragraph of new node is not necessary. After all, we are not in a condition to create new node. Therefore, new node part can be removed. What other information is necessary? Because we would need to take an action of deleting things here, therefore, we can process it a little bit. Let's rename this current. We call it the previous one to the thing we want to remove. Rename it so that we can tell what on earth it is. We can first revise the current here. Next, the paragraph counting the length of the list is the same. Similarly, we also need to know how long a linked list is exactly, so it's okay here and nothing changes. Then, if the position is wrong, we would also tell it that it was input wrong. This paragraph is okay and nothing changes. It's also okay for the paragraph to find the previous node we want to delete. Nothing changes in this paragraph, and it is also okay. The more troublesome part is that there is a new node here. Have you found it? But new node is not what we want. At this moment, we can create another node. We can call this node the node we want to remove. We create a node previous to what we want to remove, and the node we actually want to remove. Then we can replace the position of new node with the node we want to remove. But we have to revise it a little bit here. The node we want to remove is the one next to the node we want to remove. It's the node we want to remove. Okay? If you don't understand it well, I'd write it down. Let's assume the node we want to remove is the third node, the node of number 3. Then the previous one that we want to remove would be number 2. So the person you want to remove is the one next to the previous one that you want to remove. It sounds like a tongue twister, right? But that's it. After this, we would need another thing here. What we want to remove is the position of number 3. So I would connect number 2 to number 4, jump over to connect number 4, so that number 3 will be deleted later. Therefore, number 2 is the previous one that we want to remove. It is connected backward, and its next is connected to number 4. Number 4 would be the next person to whom we want to remove. As such, number 3 can be skipped. After skipping number 3, we can delete it. Skip number 3 and let it be deleted. After skipping it, delete it. That's it. I deleted the space a little bit so that everyone can see more things. That's it. Everyone can try to complete this topic. Give it a try. You can take a pause if necessary. We have completed a lot of things now. Addition and deletion are both completed. Lastly, let's do display. As such, we would know whether what we just wrote is right or wrong. If it's wrong, we have to go back to revise it. In this case, same as above, we have to introduce head, but here we call it node. Because for this node, it needs to be moved later. It won't always be in the head state, so we call it node. Here, we want to display that the head of our entire linked list would be introduced at the beginning. But because it needs to be moved later, we don't call it head so that we would not get confused. Let's write it down. Write the displaying part. Display linked list. Display list. Then enter a node inside. Okay. What's next? Next, we're going to display it from the head to the node. In the main code, we would return head here. Therefore, we would display it all the way starting from the head. So similarly, we use the way of going backward. If this node is not null, we just go backward and go and go and go and go all the way, display its data every time. For this node display its data. Then you can display an arrow to tell that I connect it to the next one. That's it. Then let's move node backward. And the next of node moves backward. Here, we just make it null directly because if we have 1, 2, 3, and 4, that is, display 1 if 1 is not null at the beginning, then go backward. If 2 is not null, then display 2 and go backward. If 3 is not null, then display 3 and go backward. If 4 is not null, then display 4 and go backward. And then it ends until it's null. As such, it would display 1, 2, 3, and 4 all. After all are displayed, we would know that theoretically it would be null now. But if you feel worried about it, you can make some determination. When it is null, we can display it comes to an end. So we see out it to a null. So the condition it displays here should be 1, then arrow 2, arrow 3, arrow 4, then arrow null. Let us know it comes to an end, instead of not displaying it at all. That's it. This is what our displaying linked list is. Everyone can try writing it. We would deal with the main code area later to look at what on earth is necessary to be displayed. Okay. Let's process the main code area. We have completed writing every function so that we can process the main code block. In the very beginning, we need to create a node called head. In the beginning, it is null. We haven't added anything yet. Therefore, in the very beginning, the head is null. Then at first, we add things at the beginning. Here, append it to add at the end. We have to tell it which one the head refers to now, then what data I want to add. We can do displaying a little bit every time, or you can display it in the end and have a look. Here, I would just display it every time. Next, continue with the head here, because we would return a node, then change our head. As such, the displaying done every time would be that actually done by the head. Next, we also put in push. Push 20, then display likewise. Let me copy this. More convenient. Next, we can push once again. Let everyone see its effect. Get a little more stuff to take a better look while doing insertion. Then display it. Next, push was done just now. Then now we do append once again. Append 40. Display it. Next, let's do insert. For insert, we need to give it 3 parameters, which are respectively which the head is, which position I want to insert, and which I want to insert with. Similarly display. Now we add just about enough. Let's delete. Delete the first one. Similarly, give it which the head is inside. Then delete the last one. Delete the first one, delete the last one, similarly display it, and delete at a specific position. Delete someone in the middle. In this case, we will tell it of which position I want to delete the data. Then I delete the data at position number 1, then display it. Okay, let's execute it. Okay, now it says there are some errors. Let's find out where the errors are a little bit. The error message here is very lengthy. However, the errors we made are actually those when we made the declaration. We kind of forget one thing. Forget to add this struct. Let me add it. Let's execute it again. Okay, it's successfully executed now. Let's see whether its condition is in line with the information we entered. In the beginning, it was added at the end. Because there's nothing, it would be the first one. It's added. Next, we added at the beginning. So here, 20, it would be before 10. Next, similarly, we added at the beginning. So 30 would be before 20. Next, we added at the end. So 40 would be put at the end. Next, 50 is put at position number 2. Then 30 is at 0, 1, 2, So 50 is indeed put at position number 2. This one is okay. Next, we delete the head here. We forgot to display here. So you can see that the head and the tail have been deleted. If necessary, you can do displaying here again. Then we re-execute it. Forget to display it. So we just added 50. Add 50 from here, then delete the head. Therefore, the 30 part disappears. Then we delete the tail. So the 40 part also disappears. In the last step, we did delete something at position number 1. Here, 0, 1, 2. So the 1 at position number 1 is 50, then 50 is deleted. This is the way we write a linked list. Everyone can take a look. Solve this problem. Regarding list, let's look at the problem of creating list. This problem hopes that we can create a list. There are seat number, name, and score, 3 types of data for the data in the list. First of all, let's process the format first. The main code is also written first. Okay, if we'd like to create a list, the most important thing is that we have to create its node first. Note: there is a seat number for the data in the list. For seat number, we use number and its name. As for the name part, we practice the way of using character here. Character array. Set one that's big enough. 20 should be big enough. The last one is score. Enter score. These 3 are the data inside. In addition to data, we also need to have a node. Connect it to the next node. Similarly, we call it next here. Don't forget that for the structure, we need to add a semicolon. This is the nodes we created in the list. The actual list we are to create. Adding data or something starts from the next problem. For this problem, let's stop here. Everyone can create this structure and this node, and continue to use them later. Now, let's solve this problem of addition and deletion in the list. This problem follows the previous one. So we can first paste here the format of creating the list above. Then start to proceed to add in the list. If we want to add the list, there is some information we need to create first, like what we wrote for displaying list earlier in class. For this matter, we can create it. Create a node. Then we want to do the addition. We have learned 3 ways of addition previously. You can pick whatever you like. We demonstrate using append to do it here. put our data inside. For the data here, we only had no data previously, but here we have 3 types of data. So all 3 types of data must be put in. Input them in our parameters. Our seat number, name, and score, 3 types of data, are necessary to be entered. Therefore, the append here is a little different from the previous one. Displaying is also a little bit different from the previous one. Need to pay a little attention. Next, let's take a look at what is required for the main code area. The part for the main code. In the beginning, we can also create a head to represent the head of the list. In the beginning, it would be in a null state. Next, we would create the data we need to input. First of all, we would need the user to input the pieces of data he wants to input. Then ask the user to input their seat number, name, and score separately. The seat number and the score are both numbers. For the name part, we use a character array here. So a few pieces of data, seat number, name, and score. Let the user input them separately. Next, we would ask the user to do inputting. You can tell the user here, please input how many pieces of data you want, etc. The number of the piece, or the like you want to input. Then you can write down your hint at will. Next, let the user input the number of the piece he wants to input. Then we would know how many pieces of data the user wants to input exactly. After it's done, you can use for loop to get the data here. Or here we can demonstrate another way which is quite frequently used. Use while loop. When n is greater than 0, it performs inputting. Then, after each input, n would minus 1. Like assuming the 3 pieces of data we input, n is 3 in the beginning, then we input something, then n minus 1 becomes 2, then n is 2 and can come in, n minus 1 becomes 1, n is 1, okay, come in, n minus 1 becomes 0, it won't come in at 0. In this case, we would input 3 pieces of data. This is about the same as the condition of our use of for loop. Everyone can get some practice. Both ways are quite common for people to use. Next, we would have our score, name, and seat number, name, and score would be input. Then proceed to add. We use append to add. Enter his seat number, name, and score, all. Call this append. For append, we will write it out later. Next, we would display how the look of this list. Therefore, we can do displaying here. We can write, the list now is That's it. What the list is now. Then call our display list. Display list this function. Remember to enter the head. This part is the block for our main code. Everyone can complete writing this part first. Okay, let's do processing our function afterward. Let's do the simpler first. Display this thing. Struct part. Put node in. Then we just go backward all the way when the node is not null. Display all its data. There are 3 types of data here. The first data is the seat number of node, then his name, next his score. You can do whatever you want to display at will. It's fine if you can tell. After it's done, he will go to the next one and continue to display until it's null. Wrong input. Next. When he is null, we can display that he is null. Tell everyone that the data comes to an end. Display it is null. This block is for displaying. Everyone can take a look first. Next, we are going to write the part for addition. Add at the end. Append. It would be all right if you want to add it at the beginning or insert it. We use adding at the end here, which is more commonly used. Because usually the newly entered data would be put at the end. We use a commonly used one to write. Enter our parameters, all. Because we want to add data, so in the beginning we can create this data new node first. Create a new node. Next, because it is to add at the end, we need to find that tail. You can also refer to the previous one, or copy the previous ones to make revision. We want to find the tail, so we create a current. Let it help me keep searching backward. Find the position of the tail. Next, the information in new node is entered. Number in new node. And the name inside. The name part here is a bit special. Let's look at it later. Then the score in new node. And which his next one in new node would point to, because we added at the end. So his next one would point to a block of null. Here, we first executed a little bit. Everyone can see one thing. Here. He told you that for this thing, you can't do it in this way. His type and data type are not quite right. There is no way to use it in this way because it is a character array. There is no way for it to be directly stored here. In this case, we need to do some more troublesome processing. Use this thing, string copy. Copy the data by way of copying. For this thing, it needs to be declared. That is, we need to include C-string. Try once again. All right, so the above matter has been processed. All right, now we still see a small problem. There is a small problem in the paragraph above. It says this name is a bit weird. When I look at the name here, I found, why is this also name here? Therefore, it's here. I just entered it wrongly. Let's execute it. Okay, so that's it. Let's continue to finish our append here. Next, what should be written in the append block? Then we would first look at whether the entire head is null. If it is null, my head would be equal to new node. Then, to directly return it. If it's not null, I need to find out where on earth the tail is. But remember not to look too much. My current must point to the last node. It can't exceed the range. So it's to use next of current to see if it is null for determination. Okay. Run and run and run and run and run in this way. Current now points to the last node. I can make the next node to current become our new node. Our new node has to be connected to the end. After it's done, return the present condition of head. That's it. Everyone complete writing it first. Let's execute it later. After execution, we would first input the number of the piece we want to input, 4 pieces. The problem hopes that we input to add these data. I make a copy and adjust it. For data, we would use spaces for separation. Commas can't be used. For commas, it can't be found. We can split it into different lines. Organize these data. Then it can add it in these data in order. After adding, it would display the present tail. We are the number 1, Shangyu Cho, and his score is 80. You can also change these arrows to the scores of or the like. You can add a number 1. It would be all right. You can modify what you want to display by yourself. Number 5, Yunhui Jiang, 50 points. Number 3, Hongyan Huang, 60 points. Number 6, Xingyi Fang, 70 points. Then the ending tag. If you don't want null, you can also draw a line. Or write, it ends here, or the like. It would be all right. Everyone can give it a try. Lastly, we're going to do the part for deletion from the list. Similarly, this problem follows the previous one. You can paste the items from the previous problem first. Then here, we are going to proceed with deletion. The deletion here and the delete middle node we did in class are exactly the same. So everyone can go to the previous problem. Copy the items from the previous problem and then process it. We can come to the previous problem. The paragraph for delete middle node above. Delete the node in the middle position. Copy this paragraph directly. Copy it to the bottom. Paste over. This is what we want. Delete the middle node, delete middle node. For this thing, we would not use it directly because we want the data of number 6 to be deleted. And for this number 6, we knew that its position was actually at the 3rd position in the previous problem. So its number 6 and its position may not be the same. That is, we would need to do some additional processing in the main code area. Let's take a look at what we need to do in the main code area. Let's start in the middle because this displays the list at the end. So in the middle block, start to process. What should we do if we want to delete the data? In the beginning, you can first tell the user what you are going to do now. We need to ask him to input the data number to be deleted or the number to be deleted. Please input the student number to be deleted. That's it. Then let him input. For inputting here, it's okay if we repeat using in. Anyway, he won't use it anymore. What's next? We are going to find this number. For this number 6, which position this number 6 in the list exactly? After finding out where he is, delete it by use of deleting the one in the middle position. That's it. So now we're going to find out where on earth this person 6 is. So we first create a current. Let it be equal to null. Let's create some variables. And I, which helps us count things. Then, what else is needed? What we also need is that we have to create a flag. To help us look at whether the piece of data is found for deletion exactly. What else do we need? That's it. If there's anything needed, add it later. Current in the beginning. And we can actually set it as head directly here. Current starts from head in the beginning. Then let it start to run backwards. Run and run and run and run and run and run until it comes to an end. Among these, as long as you find the number of our current, that is the seat number, is exactly equal to n. It represents I found this piece of data. I would let my flag become 1. It represents I found it, and then I can leave. We can start to proceed with deleting if we find it. If the flag shows the condition that is found, we will proceed to delete it. In this case, we would have to delete a position. So when you're looking for it, remember one thing. We have to do I++ to help you count which position you're at exactly. And when you're running, current also has to run backward. If it's not found, I move backward to the next. It can jump out until I find it. Is this okay? Then let's delete things. Next, we would output it if there is nothing. I didn't find this data. See out. Seat number does not exist. Seat number. Seat number does not exist. That's it. Then we can give it a try. I forgot to write the semicolon again. Where is it? The front part of 46, here. The number of the piece we want to input. Regarding the data, it seems to be in the previous problem. Let's do whatever we want. AAA, a certain score. The next one seems to be 5. BBB, a certain score. The next one seems to be 3. CCC, a certain score. The next one is 6. DDD, a certain score. As such, we should have these people. Then display same as above. The thing's displayed in the previous problem, so now we're going to delete it. I want to delete number 6. In this case, I would only have the score of A, 5, and 3, the scores of these people. Then we can try it once again. I'd copy what I did just now. Let's give it a try about what would happen if the other number is deleted. Remember to replace the comma with a space when organizing the data. Okay. I forgot to input the number of the piece first, so it's a bit wrong. Let's input first. I want 4 pieces of data. Then paste the thing above. Let me delete 5 now. Then there would only be 1, 3, and 6 left. Pretty okay. Then this is what we want. Is this okay? Everyone try to solve this problem.